counting.
It is counting?
Mm-hmm.
All right, we'll see the camera's working now. Thanks for having me. Expert knowledge, expert training to bring highway to something everybody wants. The knowledge I'm going to give you will give you the training next. The gas tungsten arc welding is a refined process. It requires expert training and skilled technicians. The information I'm going to give to you today will cover two aspects of TIG welding. First, we're going to cover pulsing current, then we're going to cover AC balance. To start with pulsing, when we weld two metals of drastically dissimilar thicknesses, we run into a big problem. One, for welding metal that's too thick or extra thick, we need high amperage to run this. In running this high amperage, we run into a problem with the thinner metal. When we run thinner metal, we need low amperage, or we're going to end up blowing holes if we run the amperage too thick. So, trying to weld these two presents a problem. In the past, people have tried using different motions and whipping the hand back and forth and trying to make things happen that little bit. It takes a great degree of skill and a little bit of luck. So, what we do is we refer to pulsing, where we set up a peak amperage and we set up a background amperage. In our peak amperage, we'll say 100 amps. We turn it into 100 amps, and we run 100 amps per fraction of a second. Then, just before the puddle gets too hot and starts blowing holes in our thinner gauge steel, it jumps down or scales back down to our background amperage, which may be 30%, for example, giving us 30 amps. We run like this all the way through the weld bead, and what this does, it gets the puddle nice and hot, keeps it fluid and liquid, and before we blow those holes, it just backs off just enough that we can maintain our puddle without opening anything up and still be able to weld. You can see that with the graph here. All it does is it jumps up here, hangs on for a second or two, there's a few split seconds, drops back down, carries on just a little bit so our puddle can cool, and moves along down the road. And this does this throughout welding. Hobart Institute has stressed this with extreme caution that it must be used only by trained technicians. It's something that you must learn and master. Okay, then there's arc balance, or AC balance, whichever you want to call it, both terms are correct. Now, if you move into this is good for aluminum welding. Non-ferrous metals have some problems. Now, when we plug our welders into the wall, we get either 60 hertz or 50 hertz, and whatever comes out of the wall is what comes out of the machine. It works for AC welding, but it has some problems. When we weld with AC, we want some negative so that we can get some good penetration. We need some positive so that we can still get cleaning action. But too much positive has drawbacks. It can cause contamination on the tungsten, and it can cause tungsten failure. So we don't need too much of it. So we refer to pulsing on this. When we use pulsing, what happens is our amperage for the DC negative cycle comes up and stays. I said pulsing, didn't I? I'm sorry. I meant to say balance. When we use balance, it comes up to our negative cycle and hangs on. We can adjust it to hang on just a little bit longer. Then, at a given set time on the machine, it drops back down to our DC amperage and gives us our DC amperage for a shorter amount of time. And we can dial this in depending on our needs and our interests and how much cleaning our aluminum needs. By doing this, we spend less time contaminating our tungsten and melting our tungsten off, and we can spend more time cleaning. You can see, if you compare the two waves, a typical wave will come up, spend just a certain amount of time in negative, move back over to positive, and spends the exact same amount of time. And it stays like this throughout the entire welding process. It can be used, but it's tricky. If we decide to turn things back where we want them, we use a little more DC negative in one side. It hangs on for, again, a good example would be about 70% of the time. Then moves over to the DC portion of the cycle. It gives us just enough cleaning, and we can get a weld with much better fusion because of the negative cycle. The end result is a much stronger weld with better penetration and a much cleaner effect. It's a much more desirable effect. Any questions on that?
How frequently is arc balance used in industry today?
Arc balance is used quite a bit. You don't see it so much in industry where they weld particularly with steel. However, arc balance is used every time you weld with aluminum, with magnesium, or any other non-ferrous metal. These non-ferrous metals have a special oxide coating that must be cleaned off by the DC positive portion of the cycle, or they will not weld properly. Any other questions?
One more. Is an understanding of pulsing and balance current control necessary for a career in gas pumps and arc welding?
Not necessarily. Understanding pulse and AC balance aren't absolutely vital, but if you want those high-paying wages like I talked about, you're going to have to understand these things. If you want a job putting gym equipment together and making $5 an hour, go ahead and skip past those. If you want a job that pays you $100 an hour out on the pipeline, you need to know AC balance, and you need to know pulsing, and you need to know how to incorporate those. So in conclusion, gas junction arc welding is a refined process. It requires expert training of skilled technicians. As you learn to apply these two things into your welding and utilize AC balance and pulsing, you'll become that skilled technician. As you master these things, you'll learn how, as you master these things, you'll get that training edge that you need. Thank you. How long did that